Hey everyone, welcome back to another math video. In today's video, we're going to be talking about the Pythagorean Theorem. So let's go ahead and let's get started. So the Pythagorean Theorem. The Pythagorean Theorem is used to help us find a missing side of a right triangle, okay? And really there's only two possibilities that we could get, two types of problems, and we're going to look at both of those. But basically, the Pythagorean states that if we have a right triangle, here we have triangle ABC, then we know that the formula to find its sides, or the sides, have to all satisfy this formula. A squared plus B squared equals C squared, here in the bottom. Now, A and B are both what we call the legs of a right triangle. C is what we call the hypotenuse, which is always the longest side, and you can always find it. Sometimes it might be tricky for you to tell which one's the longest side. If you're having trouble, just know that the longest side will always be opposite of the 90-degree angle. Okay, so we know that the two legs, if we square them and add them together, so if I take A squared, B squared, so if I do A squared plus B squared, I will indeed get C squared. Okay, and we use this formula a lot of times to help us find one of the missing sides. A lot of the times we'll know two of them, and this formula helps us find the third one. Now, A and B can actually be switched around, but if you want to sort of keep a pattern and down to the nail formula, I would say that you need to do from smallest to largest, where A is going to be the smallest, B is sort of the side that's in the medium size, and C would be the longest, if you want to do it the same way every single time. But in reality, A and B, it doesn't matter which leg they give you, you can switch them around. So let's go ahead and let's use this formula now, the Pythagorean Theorem, to help us find the missing sides to some triangles. So here I have triangle RTS or RST, and they have given me the hypotenuse, 5 square root of 10. And they have also given me one of the legs, 9. Okay, so what I want to do is I want to plug this into my formula, A squared plus B squared equals C squared. And they want me to find side RS, which in this case would be the sides that's the medium side. Okay, the medium size side. So let's go ahead. I'm going to label this missing side as B. So I know that I am missing B and I am solving for B. And they have given me C, which is 5 square root 10, and they've given me A, which is the smallest side, 9. So I know that 9 squared plus, I don't know what B is, that's what I'm solving for, squared, will equal 5 square root 10. And that 5 square root 10 is also squared, but we square the whole thing, the whole side. 9 times 9 is 81 plus B squared. Now 5 square root 10, how do we figure that out? Well, you got to remember that the 5 is squared and the 10 is squared. This is the same as 5 squared square root 10 squared. Okay, which if you do that, 5 times 5 is 25. So I'll write that down right now. And square root 10 times square root 10 is 10. So then we need to do 25 times 10, which multiplying by 10 is always easy because we just need to add a 0. So 25 times 10 is 250. Now that we've multiplied, we can actually just subtract 81 from both sides. And we end up getting that B squared is equal to, if you do this correctly, you'll get 189. If I'm not mistaken. Nope, I'm mistaken. 169. okay? So b squared equals 169. In order to get rid of this square root that squared symbol, what we need to do is we need to take the square root of both sides. So we are going to take the square root on the left, and we're going to take the square root on the right. And we end up finding out that b equals 13. So now I know that this missing side has the length of 13. So this is the first type of problem that you'll get when you're using the Pythagorean theorem. This is one of them, the first one I'm showing you, which is what happens when we're missing a leg, okay? So when we don't have the leg, we can use this strategy and use these steps to kind of help us find that missing leg. So the next problem we're going to look at, for this problem, instead of them not giving us the leg, now we are missing the hypotenuse. We're missing that long side. So we're missing our C. We don't know what C is for this one. So now when we plug into our formula, we were given A, which is 10, the smallest side, 13, which is that middle length side, and then we are missing C. So we're going to leave C alone. So I would actually get 10 squared plus 13 squared, and that's going to equal C squared. Multiplying, we get 100 plus 169 equals C squared. 100 plus 169, that will give me 269 equals C squared. Now I can take the square root of both sides, and I find out that C is equal to the square root of 269. And for this one, we can't really simplify 269 as a square root. That's actually the simplest it can get. Sometimes you can simplify these radicals. You can also, if you wanted to, write your answer in decimals and actually find out what the square root of 269 is, but we'll go ahead and leave it here. So the problems where you actually find the hypotenuse, they're most of the times a little faster because you don't have to subtract from one side of the equation to the other. It's just adding the two legs after they've been squared and taking the square root of them. So hopefully now you feel like you can use the Pythagorean theorem to solve for missing sides of right triangles, okay? Again, this is really the only type of problems you see when you're working strictly on the Pythagorean theorem. Now, there will be other problems where you have to use the Pythagorean theorem in that problem to find something else. But like I said, if the problem is strictly just asking you to use the Pythagorean theorem, then this is the type of problems that you would see. You're either going to be asked to find the hypotenuse, or you're going to be asked to find one of the legs. As always, I just want to thank you for watching. I hope you can continue to learn, and I'll see you guys next time.